What's up, guys? This is Milos. Welcome to my channel as I take you on another data visualization and mapping journey with R. This time, I want to show you how you can create crisp and effective river basin maps in R. River basin maps are extremely important for water management, flood management, pollution control, water quality control, but also ecosystem conservation. And there are a lot of beautiful maps around, some of them done in Python, but I would wanted to make sure that we can also make similar effective maps in R. So here we are with yet another tutorial, and we will be leveraging HydroSHEDS data again. We will be downloading the river basins as well as river streams into R. So first things first, I will show you where you can find this data, how you can download it, unzip it, and then load it into R. Then I will show you how you can create a river basin maps for specific country. We'll be creating a river basin map of Brazil. So without any further ado, let's roll. All right, guys, let's kick off our adventure by first of all loading the packages we need. In today's session, we're just gonna use 3 packages. Let's start off by defining a list of packages that we are going to load in this session. First library we need is the umbrella package Tidyverse for data wrangling and data visualization. We used it so many times before, and Tidyverse is useful here for actually dealing with columns, modifying them. For that we can use dplyr, and then also for data visualization, for which we're going to use a ggplot2. Then, because we are here working with polygons, basins and rivers here are in polygonal shape. It means that there are also shapefiles. So we will need SF package to be able to load them, modify them, crop them, merge them in any possible way. And then finally, because I would like to create today a river basin map of Brazil, I also need country level boundaries of Brazil, and for that I can use GSCO-R. All right, the next thing is to check whether these libraries are already installed on our machine, and if they're not, to then install them. So we will actually create a new object called install libraries, and then we're going to expect this libs list in search for row names of already installed packages. So then we will actually see here among the installed packages if they are actually installed, and we're going to store them in this installed libraries object. Now, if they're not installed, we need to write an if-else statement. So if any of those installed libs that we just or installed libraries that we just created, if they're equal false, so if they're not there, then we open up this curly brackets, and then we tell R to install packages, and among the list of libs which are not stored in installed libraries. This will make sure that we install. And finally, we want to load everything. So for that purpose, we will simply use lapply, which is the function used to apply something to a list, since we're here have a list of libraries. So we're going to apply to the list of libs. We're going to apply the function library in R, which is actually used to load packages. And then finally, this is going to only apply to the characters. All right, once we have this and we run everything, we should be able to install the missing libraries and then to load them. And then finally, we can start downloading those river basin and rivers shapefiles. Because we want to create a river basin map of Brazil, it's totally in order to first of all load the national boundaries of Brazil using GSCO-R. So let's create a function called getCountryBorders. And then within this function, what we're going to do is we're going to call GSCO-R, and then we're going to use get GSCO countries. So there are a lot of functions here, but we need GSCO get countries. And then for the resolution, so this is how crisp, how many details your shapefile is going to have. We can take, for example, 3. The crispest one is resolution 1. You can choose also those that don't have such sharp boundaries, for example 10 or 20 or I think even 50. And finally here for the country, we use ISO to code in letters, and Brazil is, for Brazil, it's BR. So we can actually define this as country borders, this object, and as a part of our function, we also need to return this object. Finally, once we have this function defined, we can call it and get the boundaries of Brazil. In today's tutorial, we will again be working with the HydroSHEDS database, and this time with its hydrobasins data. We will be aiming to create something like this. So here you can actually see a map, world map of river basins with the lines in black and then rivers that belong to them. So we would be focusing on creating the river basins for Brazil. So for that purpose, we'll be downloading one of the polygonal files from this website. Is going to be this HydroBasins website, which is a place where you can find hydrological basins developed by this World Wildlife Fund and the South Dakota State University, which provides hierarchical system of basin delineation and multiple spatial scales. So what you can see here currently on this map is the level 2 of hydrobasins, hydro level 3 of river basins. So we will be downloading also that level. If you want to learn more about the hydro basins data, you can definitely go ahead and check out this HydroSHEDS technical documentation. So if you click here, you will actually find more information about the data sets, what it is, how it was measured, how it was done. So there's a ton of things here, but for us, what is really important, if we go back to this hydro basin, is that we are actually going to be downloading a level 3, but that doesn't mean there are not more levels. So since Brazil is in South America, we expand actually this tree leading to the South America data, we'll actually find here a very interesting thing. So HydroSHEDS has 12 levels of basins, and you can actually download the complete data sets, which is over 300 megabytes, but it has then these different basin layers from level 1 to level 12. So what does it actually mean? Well, level 1 is the highest level. So these are basically just the largest rivers and then their basins. Every next level includes sub-basins. So the one that you see on the map, as we said, it's level 3. So this is the basin that we will be downloading. So it's a level 3 basin. So it's 3 megabytes. So one thing that you can do, you can simply click on this to download. But what I like to do is I like to copy this link address here. So this is what I actually did, and then we're gonna use it back in R when the time comes. So in order to nest rivers within river basins like it was done on that map, we will be using another dataset from the RiverSHEDS, and this one is Hydro Rivers, which actually shows you different rivers based on their sizes. And we've already used this one in the previous tutorial where I show you how you can create a European river map. So what we'll be doing here is we'll be simply downloading the shapefile of South America rivers, which is 95 megabytes. Of course, it's a zip one, so it's a bit bigger. So what you can also do here is just click on the download or simply copy the link address. I suggest that you copy the link address to the South American file, and then once we're back in R, we are going to plug it into the code, and then we are programmatically going to download, unzip, and load into R the same way we will do also with the basins. Now that we have copied those links to the basin and river shapefiles to our clipboard, we can finally use them in R to first of all download them, and then once we download them, we unzip them and then load into R. We will start off by first of all downloading and unzipping and loading into R the basin shapefile. So here I actually pasted this link that we copied before. So these are the level 3 basins for South America. So let's actually define a function called get basins. And then within this function, we're just going to use base R functions. The first one is to download the file. So before downloading the file, we need to define the URL. Luckily for us, we did that. So it's this long one that we previously copied. So we're just going to store it here in the form of a string. Once we do that, it's also very convenient to define the file name under which we will download this. So remember, this is going to be a zip file. This is the actual name, which you can also use, but you can also choose to go, with something else. So, we can just go with this one. That's totally fine. Now, we can finally write the downloads file function. So here we need to specify the URL. And for the URL, we already specified the URL, so it's defined. The second one is the actual name of the file. This is handled by the dest file argument. So here we plug in this file name. And then finally, we define the mode for downloading to be binary. And then finally, within this function, we can also unzip the file that we just, downloaded to our local drive. And again, we're going to use base R function unzip and just pass this file name to it. Finally, what we can do next is, outside of this function, just call a get basins. And then when we run this, what will happen next is that we will start downloading the file name. It's going to be saved under this name on our local drive, and then we're gonna unzip it, and after that we can finally load the basins into R. Alright guys, if you followed all the steps that we did, once you download that folder, you unzip it, and if you're working in a newly created directory where there is no other files around it, once you run this list files, you should be able to see these files. So these are the shape files, and there's also this PDF file which just serves as guidelines to understanding what is the data that we downloaded. So what we need to load next is this number 5. So this is the shapefile name that we're gonna load. So for that, let's write a function in R, load basins. And then this function is going to be very simple in a sense that we're just going to use SF package to load. So if you want, you can simply use that name that we just printed. But if you want to make a more automated function here, which is going to just grab what you need, you can also go for file names here. But be careful, this is not actually going to work if you have more shapefiles in your folder. So if you have more shapefiles, I just suggest you copy and paste that name of your shapefile into the one of the next lines that we're going to do. If, however, you're working with a fresh directory like I am, you can simply do this list files and then search for pattern, which is actually shapefile, .shapefile, and then ends here. So you use this $sign to just say, don't look for anything else after this .shp. And then finally, you can also say, okay, please look for full names here. That's true. Okay. And finally, we can load this. So we can call it S America basin, and using SF st-read, we can finally read these file names, or actually file name in this specific case. And then finally, we can return this newly created S America basin object here, and then also call it outside of the function, or actually calling this load basins function. All right, so now when you actually run this should actually return that object. So we're going to now plot and see how this level 3 basins looks like. Okay, so here it is, the level 3 river basins for South America that we also saw on the HydroSHEDS website. The next thing is that we will crop this area using the Brazil National Boundaries shapefile, and then we will just get the river basins for Brazil. Okay, we're ready to create Brazil's river basins by clipping that bigger South America river basins object. But before we do that, it's really necessary here to turn off the spherical option in the asset package, because otherwise some of the vertex sizes are not going to be able to be, intersected and then clipped. So we just turn this off, and then we create a new object called Brazil basin, where we're going to work based on this S America basing. So for clipping it, we put it first into a pipe, and then we call SF and ST intersection from the SF package. Here we want to clip by the country borders, which in this case are Brazil's boundaries. And then finally, we don't need all the columns there, so we want to make it easier a bit for our machine. So we're just going to create the basin ID fields. Okay, and then if we run all of this, we should be able then to see the newly created object. If you followed all the steps so far, you should be able to see a plot like this, which are river basins for Brazil. In a similar fashion that we downloaded and then unzipped and finally loaded into R, that river basin shapefile, we're gonna do the same for rivers. So here I actually pasted that link that we previously copied when we went to the HydroSHEDS website. This one are simply rivers for South America. Again, we're talking about the shapefile format, so you can see here in the name SHP, but it's also zip for now. One more thing, this one actually comes with a subfolder. So the main folder that we will be downloading here will be this Hydro Rivers V10 SA, so for South America. But then within this one, we will have the actual shapefile. So let's see how this actually looks like. So we are first gonna, again, define a function, which is going to be called getRivers. And getRivers function is, as I said before, it's basically identical to what we already wrote. So the only difference here is the way we define the URL. In a sense, it's a different URL, but the principle is the same. So it needs to be in a string format here. And then again, we can define a file name. File name can be more or less the same, but let's say this time we just say SA rivers.zip again, because it is in a zip form. And then again, we use download file from base R. For the URL, we pass the URL object. For the dest file, we pass this file name that we just created. And then finally, for the mode, we use the binary mode. And then finally, once we download this, we can just unzip the file name. And last but not least, we just call this function, which is gonna get those river shapefiles for South America on our drive, and then it's gonna unzip this folder. If you run list files again after downloading and unzipping, what you will notice here, element number 11 on the list of files is called Hydro Rivers V10 SA SHP. So this is actually a folder. Within this folder, we will find all those river shapefiles. So what would be very useful here is that you just copy this string, because we will use this pattern to then pass it to R and tell R to actually, load. And this is the next step that we're going to take. So loading rivers. We're going to create a function called load rivers. Again, it's going to follow what we previously did when we were loading basins. So we're going to be using the same, function, which is, stRead from the asset package. And again, if you are working with a newly created directory or the one where you just store these files, just follow now this code. If not, you can directly just do stRead and then the name of the shapefile that you want to read and the location of it. So this is how we're going to do it. It's again list files, and then we're going to create a path here declare. Now a difference from the previous one is that in the previous one, we were just looking for a shapefile pathway, but this time we need to actually define that there is a folder where we need to search for that pattern. And the pattern is again the same as we did before. So it's going to be .shp ending with the $sign. And then finally, also we're going to be using full names here. Now, once you have defined this object file names, you can actually use it and pass it to st-read. So we can create a new object, which is called South America rivers. And using st-read, we can pass it here. So if you skipped this first chunk on file names here, you can pass actually the name of your shapefile that you were, that you want to load. So here we just pass file names. In your case, it might be a string. And then finally, we just return this newly created object, which is called S America rivers. And once we define the function, we can also call it, and the name of the function is load rivers, which is going to create this object. So let's now load this file, and after that we can crop only the Brazil's rivers. Now the same thing we did with the river basin, we're also gonna do with rivers. So we're gonna crop them using st intersection. So for that purpose, we're gonna go and create Brazil rivers object. This one is gonna call S America rivers and put it into a pipe where it's going to, well, first of all, what we can do here is actually create only, or actually select only those columns that we need. So we are going to use only the size of the rivers here, which is denoted by ord_flow. And then we're gonna go next to the pipe here. And then finally, we can here call the st intersection once more to rescue. And again, use country borders for this. Now, once you run this is going to take a bit longer than in the previous case. This is because there are a lot of lines here. There are a lot of rivers. And also Brazil is a big country. So on my machine, it took around 8 minutes. So, just to buckle up, get a coffee or something else, and wait until it's done. The Brazilian river shapefile is still quite large, so we're not gonna explore it or plot it at the moment because it would take a while. Instead, we are now finally ready to determine a basin for every Brazilian river. So to do that, we will be using again st intersection function from SF, because when you do intersection here, what will happen is that all the rivers will actually inherit that hydrobasin ID from the basin shapefile. So basically, when doing the intersection here, we are also assigning, we are actually merging and joining them together. So let's create a new object, which is going to be called Brazil River Basin. And we call, as we said, st intersection here. So what we're going to do is we're going to intersect rivers with basins. So the first one will be Brazil rivers, and then the second one will be Brazil basins. The reason why we do in this order is that because we want to assign specific basin IDs to the rivers. So this is going to achieve that. If we, for example, wanted to find, okay, what are the river IDs that are assigned to the basin, then we would do reverse. But in this case, we want to do this. So one, again, sign of caution, we are again using st intersection. Again, we are applying to the rivers shapefile, which is quite big. So bear with me, this is going to take a few minutes. But once we do this, we'll be finally ready to prepare our data for plotting. We have a lot of rivers, even in the newly cropped shapefile for Brazil. So if we just go ahead and plot those rivers, it's going to be a jungle. It's going to be chaos because we won't be able to discern, bigger rivers from the smaller rivers. For that reason, we're going to go with a technique that I also used in the previous tutorial on mapping rivers with R, which is creating specific widths and assigning them based on the actual size of the rivers. And this is where we can utilize that ord flow column from the rivers shapefile. Now, before we can actually dive into that, we need to actually check what are the actual, sizes. So there can be 1 to 10 values of sizes, but it depends actually what our, Brazil shapefile captures. For that purpose, we will use unique function from base R, And then we are actually going to go for this Brazil River Basin and ord flow and see, okay, what are the unique values for this column in specific. So I'm just going to actually increase this terminal here. So what it says here, the values go from, so obviously they are not ordered well because this is a factor. So from 1 to 9. Okay, good. We now know what to work with. Next thing is, let's create a new object because previous operation took a while, so we should not actually work, append it. Let's actually better create a new one, which is going to be called Brazil River Basin Width. And then here we are going to use dplyr mutates, which is used for creating or modifying existing columns. Well, we're going to create a new one, which is called width. And width, first of all, we are going to turn into an integer that ord flow that we just saw. And after we do that, we are actually going to assign values to every ord flow. So why are we actually doing that when we already have values? Well, because in ggplot2, sizes operate on a range from 0 to 1. So if we just pass those, from 1 to 9, and we're gonna get gigantic lines all over the map. So in other words, we need to scale them a bit. And this is how we can achieve that. So we can use from dplyr function, which is called case when. And this function actually originates from SQL, where you can actually, based on the value that a column has, you can assign a different value. And this is how we do that. So for example, for the width order of 1, so these are, the largest rivers denoted by 1, and those with 9, they are the smallest rivers. So for these, we want to give them a very, very broad lines. We want to make them large. So we then use this sign to assign a new value that would appear in ggplot2, and we'll say, for example, say 0.8. 0.8 is actually, quite big because it's very, very close to 1. Now, the thing is, we now need to go and for each of those values assign something. So we did this for order of 1. For order 2, we should go a bit lower, let's say 0.7. It's still quite visible. Then order of 3, we can go even lower, let's say 0.6. Then order of 4, we can go for even smaller one, let's say 0.45. Then for the width of 5. So as you can see, we're just going lower and lower with this sizes here, and until we get actually to the size 9, which is the last one, and which is actually the the smallest river in the current data set. So 0.2, for example, and then with 8 could, for example, be 0.15, and finally the width 9, can be a 0.1, and then finally for all those values that are not assigned, we can just give them a sign of a value of 0. So basically, they're not gonna, show up on the map. So this is how you actually create river widths. And then finally, this is going to turn into data frames. So we want to put it back into the SF format. And for that, we use st as SF function from the SF package. We're finally ready to create our map with the help of ggplot2. So let's get down to it. First of all, we're going to define object P, and then we're going to call ggplot function as usual. And after that, we're going to go and create our one and only layer, which is going to combine river basins and rivers of Brazil together. So within this one, for our data, we're going to grab that last created object, which is called Brazil River Basins Width. Within the aesthetics fields, which we need to define because we are plotting this as the layer, we're going to have actually 3 variables. The first one is going to be the color of the basin itself and all the rivers that belong to the basin. So they're going to have, every river that belongs to a certain basin is going to have a unique color. So for the color here, we're going to turn this into a factor. So we're going to call this HydroSHEDS ID. The second aesthetic option is, of course, the size. So the size, for that, we're going to use the newly created width column. And then finally, if we want to create even a better effect of the sizes, so give more transparency to smaller rivers and less transparency to the bigger ones, then we can also use alpha here. So in other words, we want to have larger rivers to be more visible than the smaller rivers on the map. So again, we can use width here for the same parameters. And that's about it when it comes to defining the main layer. After that, we can customize, all of these things, including color. So we can customize, the size, the alpha, and everything. Let's start off with the actual color. So because we're working here with categorical value of basin ID, we need to specify scale, color, manual. If we, however, worked here with the continuous variable, we would have specified scale, color, continuous. So within the scale color manual, there are several things that we can specify. So one of them is the actual name of the legend, because here we are not actually going to show the legend with the basin names. You can, of course, change that, but for now, I'm just going to keep this empty here. So we're not going to go for it. Second thing is values argument. In the values argument, you specify the colors. So for the categorical colors, we can use something that is native to R itself. And this one is called HCL.colors. Check this one if you haven't, because they have colors for categorical, diverging, sequential values. For us, we need the categorical values. So we already checked rivers that exist there are, 9 type of rivers, but for basins, we didn't really check. So we can actually do that right away here. Let's check how many basins we are working with so that we know how many colors we need. So first of all, let's go like this. We call Brazil River Basin width, and then we call this column HydroSHEDS ID. So let's actually check how many unique values are just available here. So it says here 14. Okay, that's good to know. It's really good to know, because in this one, HCL.colors, you actually need to specify how many values you need. So we need 14. I mean, that's a lot, but the advantage of this package is it is actually going to assign specific color values that are also colorblind friendly. So we should not be having problems distinguishing among different rivers and river basins. The next thing that you can choose is a palette. So actually, let me show you what are the color palettes that HCL operates with, especially talking about here qualitative palettes, qualitative or categorical. So if we run this, we will see actually quite a few of the options. So this one is actually not working because you need to specify not colors but palettes, which is a shorthand for palettes. So if we run that again, you will see here at least 9. Spoiler alert, they're more or less similar. What actually differs here is the level of transparency assigned to them. So I like to use this dark 3 because these are kind of the strongest colors. They're not pale as the other ones. So we're just gonna go for this dark 3 set, and we're just gonna paste it here. So this is what we're gonna use. And then here also you can choose the transparency level. I don't want this colors to be transparent, so I'm just going to go for alpha 1 because we already defined here, transparency. So we don't want to define that once more. Okay, so this is how you define the color, values. Then we can, go on and deal with scale size. So scale size is another way to customize, the sizes. So here we can provide a range in R, of course, range of sizes that we want to use. And what I like, so sizes here can go, everywhere from, 0 to any kind of number. but I think after 1 they really become very thick. So for the lower bound, I would go for something like 0.1, so they're still visible, and 1 would be the upper bounds. So you might be wondering, okay, we already defined in the width, these sizes. Why do we define one smaller? Well, the thing is, this is where you programmatically in ggplot2 decide how much actually thickness ggplot2 will assign based on the values that you did. It sounds a bit complicated, but this is how it actually works. The second customization, or the third actually, and the last one, is the alpha value. So again, we use scale alpha here. And again, because we are working on a continuum of transparency, we can define here a range. Same like for the size, we're here talking about 0 to 1, where 0 is completely transparent and 1 is complete absence of transparency. So we would like to have this range from, let's say, 0.01, but not completely to 1. So we don't want to assign, to Rivers complete alpha value. So let's say we're going to go for 0.3 here. Of course, with all these customizations, you can play and see what actually works for you, what creates a better plot for you. Once we're done with customization of the layers themselves, we can move on and customize the plot itself. I like to use theme voids because it's going to get rid of some, additional stuff around the plot itself. And then within the theme argument, I like to play with some additional, information. One of them is, for example, legend position. Because in this tutorial, I'm not going to use, the legend which shows, whether the river basins. I'm just going to turn it off. But if you are going for the legend and you want to have legend position, you can put it on each 4 sides of the world. So here just specify, top, bottom, left, or right, or you can provide, a list of 2 values, X and Y, which then specify the coordinates where the legend will stand. So a legend is one of the things that we want to have. We might also want to have, a caption here. So I would go for caption, plot caption. And then if you are dealing here with captions, titles, or other types of text, you need to tell ggplot2 that you are working with text. And the way to do that is using this element text argument. So for the caption, we can, for example, go for a smaller one, let's say 9, and the color itself doesn't need to be that strong. So we can go for, let's say, 60. And then, for example, you can also define horizontal justification. So this is how much, your text is going to move from, left to right, where left is actually, 0, right is 1, and middle is 0.5. So I want something to be more or less right justified. So let's say 0.1. And vjust is the vertical justification. So here I would like you to push it a bit up. So for that, you need to use values higher than 0. So let's say, for example, 10. Here we can also use, other things. For example, the title, if you want to have a title, but I think it's obvious what we're doing here. So we're creating a map of Brazilian river basins. So that's not really necessary. One last thing that we can do here is define the margin. So we can basically just shrink the space around, the plot. So for example, plot.margin equals units. And then within this unit, you can then specify in the form of a list what you're actually going to do. So if I want to, minimize the white space around, I'm just going to assign zeros to everything. So T stands for top, R stands for right side, B stands for, bottom side, and then left stands for the left side. So I want to shrink for all of them. And then here you can specify what are the units that you want to use. So that's more or less the basic stuff here. Now, if you want to add a bit more flavor to your plots, what you could do, because we are talking here about multiple colors, multiple levels of transparency. So what we can do is we can actually plot this against a very dark background. So the way to do that is the following. You need to specify here plots.backgrounds. Plot.background, And now this one is not text, this one is a rectangle. So element rect. That's how you define. And because we want to fill up the background, we're going to use fill here. And let's say we're going to just, fill it with black color. And then for the color of the edges, we don't need to have them, so we can just put here NA. Now, this was for the plot itself, but there is also a wider thing than the plot, which is called panel. So you also want to fill up the panel background in exactly the same way that you fill up the plot. If you have a legend, you should also fill out the legend background. So the command for that would be legend.background. Now that we defined our theme, the final thing is also to maybe put some labels here. Function labs or argument labs in ggplot2 is the way to go. So here we don't have a title, but if you wanted the title, you could just say title equals to, and then you provide a string. So for example, we don't need a title. We also don't need this, X one, and we don't need the Y one. But what we can also provide here is, for example, the caption. This is why we define the caption parameters above. So here, for example, what we can do, we can say, the source, and the source is, the World Wildlife Fund, HydroSHEDS database, and then with the link to the database itself. So this is, for example, how you could potentially, do it. You can put that into a caption. All right, so more or less that would be it. So once we have all this, we can simply run this whole code for the P, and then after that we can see what is the map that we got and if we are happy with the map. This is how the first version of our map looks like. I'm not super happy with it. I think for one, it is a bit dark, and I do think it also lines that don't stand out, and they're maybe a bit thicker than they should be. So I think we should go back to the code and play a bit with that scale alpha and scale size until we get it right. All right, we're back, and I think one thing that we need to change here is the scale size. I think this is creates really, really thick rivers, especially those of higher levels. So instead of going for 1, we can decrease it by 30% to, for example, 0.7. And then the second thing is that it's quite dark, and it's dark because our alpha levels, even the upper limit, is quite low. So we might also want to put it closer to 1. And let's, for example, go for 0.7 here, although we could even go higher. And once we have this, I'm not going to change anything about this. So we can just, check this out and then also save it. So by the way, these are the inputs that I used. I would just maybe decrease this to 7.75. So these are my parameters for GGSave, a file name, and then width and height. These are in inches. I use the PNG device, and this is the resolution of 600. And for the background, I choose white, even though I could actually choose black, but this is just not to have a transparent background. All right, here it is, the final map. I'm way, way happier with the outlook of this map now because there is definitely more visibility. Also, the largest rivers do not dominate the landscape that much. This looks pretty awesome, guys. This looks like arteries of different basins based on, the river flows. So I'm pretty happy how this looks like. If you, however, prefer the light version, you can also get rid of the black background, but it might not give this accentuated, outlook. Also, I think you can definitely apply this to other, countries and see how this works for you. And you can also play with different color palettes. That's all for today, folks. In today's tutorial, you learned how to create effective and pretty river basin maps using HydroSHEDS database. Today, we created the river basin map of Brazil, but I'm really excited about your own use cases and how you can take this tutorial on a journey across the world as you create your own beautiful river basin maps for other countries. If, however, you would like to replicate today's analysis, I've prepared a link to a GitHub repo in the description below. Feel free to clone it, reuse it, modify it as you see fit. If you have any questions, comments, or just general feedback, you can reach out to me here on YouTube, but also on Instagram and Twitter. If you are new to R, or you simply want to expand your data visualization and geospatial knowledge with R, I prepared a few tutorials for you. See you next time.